Thank you so much. And yeah, we made it as difficult as possible for you to say that by naming it this. Thank you so much for coming. I know it's right after lunch, so I appreciate you all showing up and not sleeping just yet. We're just going to walk through the agenda here, talking about our cloud journey, more importantly, who Ally Financial is, complications we've faced along the way, solutions that we've pursued, kind of go into a deep dive of what we've settled on, and then what our outcome and future roadmap is. This is more of a really implementation of like what we did and how we've adopted FinOps principles and what's worked for us and what we hope might inspire and work for you. So we'll start with Ally Financial's cloud journey. So it's probably a good start to let you know what Ally Financial is. We're a leading financial services company. We offer full service banking products. It's loans, insurance, investments, all with no physical presence. So everything you can do with Ally Financial is all done through the app. You can call in if you want, but we recommend the app. Being a digital first company, we've a handful of legacy AWS accounts, Azure accounts, the usual things, with no real central strategy, starting in 2014. In 2018, we did a hard reset of our cloud strategy, and basically we tried to centralize everything into a hub and spoke model, which is something you've probably heard a couple of individuals talk about during this conference. We wanted to focus on infrastructure as code and scalability. Since we're a smaller technical team, we can't do a lot of click ops. We can't go into each individual account and build things for our application team. So our objective was to use Terraform and other infrastructure as code tools to really enable our teams to build as fast as possible while still maintaining sort of rigor and audit-ready position that a financial services company needs. So now we've got about 100 accounts in AWS, multiple Azure subscriptions, and GCP integrations as needed in a business unit-oriented 3-tier structure. So a dev account or a dev environment has its own account. We've got a test account, and then also a production account where our actual workloads are running. So because of the way that we do this, we've got a lot of applications all coexisting within individual accounts. So that's really important for me to bring up because it can get complicated, right? If you've got one app team running in one account and then another app team is launching their application next to it, it's possible they can step on each other's toes. And so being able to manage that from a least permissions perspective while also talking about cost allocation and the tagging that's required in order to manage these things is important. And we also use the Showback model rolling up to a single payer account in AWS. It just makes things a little easier for us. So kind of going into the complications, I mentioned that briefly. We had multiple apps in single accounts. So previously, if you had 2 databases both running a workload, you didn't know which one was associated with what app. And so it was really difficult. And then on top of that, because we have 3 separate accounts, like in a single business unit, the AWS tools weren't really built back in the day to really associate costs from those 3 different accounts all up into one single pane of glass. And so we didn't have any accountability for costs. We didn't have really any monitoring or anything for cost spikes, which meant that we either saw them and did nothing, or we didn't even notice them, which is even more scary to think about. And then our RIs and other instruments for saving money in the cloud was really hard to optimize. And then ultimately, I think everyone's probably felt this experience. You've got abandoned cloud infrastructure out there, and there's really no good way to clean it up, right? Especially if there's no accountability. So what did we try to solve, or how did we try to solve it? We started by, again, leveraging our infrastructure as code capabilities. Basically, we started by allowing developers basically no write access in their environments in production. So what that meant is you were forced to go through a pipeline, and when you're forced to go through a pipeline, and use Terraform or infrastructure as code, we can start baking in a lot of controls and a lot of tags to help kickstart the cost allocation process. And so that's what we did, right? We basically said, hey, we've got these pipeline tools that we have. We're partnering with our DevOps team, and we're partnering with our security team to enforce best practices. Why don't we also bake in these tags and these other tools into our infrastructure as code, which basically gets us a lot of capabilities for free. And then that's from a proactive side, right? As developers are developing their code, they're building their applications, they're getting all these tags and features baked in for free. But then on the other side, on the management perspective, we're using SCPs to help enforce things. So even if you didn't deploy something through a code pipeline or through infrastructure as code, we were using the SCPs to require like application IDs, individual workload identifiers, to be initialized and put on top of those resources. And so once we had that in place, we actually could start building these self-service portals that would allow us to kind of aggregate across different accounts, even across public cloud providers, to allow us to really enhance visibility into the developer applications, but also give them tools that is like tailored to their specific application, right? Certain applications run on servers, others are serverless. Those tools and those capabilities all depend on what app is actually running. And then within that, right, we've got Slack channels and other constant feedback mechanisms that basically redirect our developers to the portal basically at every moment. And the objective here is just to drive those developers to the portal so that we can have conversations about improving their cloud platform and basically improving their applications. Sorry. So that's a huge setup for the AutoMagic App Platform, is what we call it. And the whole idea is, how do we do these things as easily as possible for people so that they don't have to be the experts about FinOps or DevOps or any of the other ops? And how can we do a lot of the heavy lifting for them? And so for version 0, we built it on AWS resource groups. It worked really well. It's like a metadata service within AWS that kind of collects and aggregates things for you. The problems you run into, though, is that it doesn't scale across counts, or it didn't. It does kind of now. And as soon as you try to go somewhere that's not AWS, you lose that visibility. And so we kind of hit a brick wall, and we pivoted quickly to an open source technology called Cloud Query. And it basically abstracts all of the various APIs that you're interested in for managing cloud into a way to collect that data and consume it in a SQL, a standard SQL format. And so what that lets us do is now, we don't have to spend hours and hours building custom scripts to go and collect all the information about all the different Lambda functions across our hundreds of accounts. Instead, we just have Cloud Query go through and collect that information. And then, furthermore, we don't have to train analysts or anyone else about how to query this data. It's already standard SQL. So they can just do stuff like select star from AWS Lambda functions where encrypted is equal to false. And so now they can automatically get all that information without having to learn a new tool, without having to learn a proprietary language set. And best of all, it's open source, which means that as we've adopted new tools within our cloud platform, we're actually able to contribute back and build the tool in the way that we want it. So it really lets us build this holistic end-to-end view of all of our cloud applications. That means everything from Azure, GCP, GitLab, Datadog, all these big tools. We can actually build an end-to-end view of that application, and it gives our app teams a really great way to understand their application from start to finish, all in one place. So that's a lot of stuff not about FinOps. So here we are, right? AutoMagic App Budgets, the title of the talk. What we identified is that once we had all this information about the data of our applications, now we can actually start building budgets and things for our app teams, right? The whole point of this platform was to enable our application teams to not sweat the small stuff, and instead we can build it for them. So we're kind of diving into the weeds here, right? The new application IDs, that's our universal workload management tag that we enforce on everything. When we detect a new application ID, and again, that's through our data collection process in Cloud Query, we actually go and request to our AD group and our email capability, hey, can you make a new email? And in that, what we do is we cross-reference the GitLab repositories, and we also cross-reference the people who actually have write access to the repository that owns that application. We kind of stuff them all into a group, so that way we can do targeted messaging to these application teams. So, kind of peeking forward, right? If you've got a budget and you breach that budget, guess who's going to get an email, right? It's specifically this application team. You've got a cost spike that went out of control because of a DynamoDB table or something. We can send you a specific targeted email with high priority saying, hey, it seems like something's up. Have you looked into it? And we can follow up, and it kind of enables that conversation that we're all looking for. To do this, we also use AWS budgets, and these are set initially at $1, just because sometimes we get applications that show up one day and then they're gone the next. We don't want to really sweat too much. But when people actually start using and building these applications, right, their budgets kind of balloon. And because we see that ballooning, they go over $1 a month pretty quickly, and we can see that 1,000% growth, for example. And we know who to talk to, right? Because we already have their application ID, so we know who owns the app. We know the developers, so we can talk to the lead. We can make sure that they're getting the support and the resources that they need, and all the while managing their costs and keeping an eye on it and a pulse on things, all without having to do anything really. So that's all well and good. That's a lot of text. This is what it actually looks like. This is our Vue.js application. It runs on Fargate and leverages a bunch of Lambda APIs. It's all serverless. We don't sweat anything about that. It's great. And you can see this is we can walk through. It's pretty resource rich. But you can see front and center costs, right? Our objective is to help people manage their costs. A lot of times apps don't even know that AWS costs money just because of the way that our organization is set up. You can see off to the right, we've got savings suggestions. That's pulling directly from Trusted Advisor and some other capabilities that we have. And, it's saying hey, your massive EC2 instance probably doesn't need to be that big. Have you considered, updating it? And then we have, some of the other things are less FinOps optimized here, but cloud adoption. We want to encourage people to actually use our tools. We want to lower the barrier to entry to leverage our patterns and things like that. So we give them a cloud adoption scorecard, some security stuff, which is really important. Our CISO loves that. And then also deployed environments. And then I've also recently heard a couple talks during the thing about scoring and automatic evaluation of applications, and how do you know if they're doing the right thing, and how can you sort it? Because a budget is not always the best way to make sure that an application is actually doing the right thing. And so we developed a Cloud Smart Score. It's kind of like what our friends at Target were talking about, the Coin Cloud Optimization Index in a previous talk. But it looks at, it's more than just the finances. It looks at the actual architecture decisions that they've made in terms of serverless or not so serverless, and also costs and overruns and waste. So it helps us kind of say, okay, who's our 5-stars apps? How we talk to them? How have we kind of shown off what they're doing to the rest of the organization? And then it also helps us talk to the 1-star apps, being like, hey, we know you're having a hard time. We see all these issues, and we want to help, right? We're the experts. We're building this platform to make it easy for you, but that's really what we're going for. So again, as these app teams develop, this is kind of the nuts and bolts how we do it. We got a 3-month look-back window, so you're building for 3 months. It kind of gets you over that initial build bubble. And then we just set it, 10 plus 10%. And the best part is that it's not locked in. App teams can actually request updates, again, through that UI, and we can approve them. So each app manager themselves is actually able to say, hey, I know I'm going to have a big database. It's going to be $1,000 a month. $1,000, and they submit it, and through our intake process, we're able to actually validate that, that's a reasonable budget to be sent. Again, using AWS budgets, we have some built-in alerting capabilities. So alerts seems like a strong word. It's more like warnings, like, hey, 50% and you're on the 5th of the month, you're going to have a bad time. And through that, we can send these emails and notifications. We have Slack integrations as well. But for whatever reason, email sticks the most, we've seen. And then also, we've got these notifications displayed prominently on the API. So like I said, right, you can see we got a nice green happy check mark. We're on track. Yay, everyone's happy. If you're off track, it gets progressively more red. And then, like you can see there on the bottom, we've got a weekly intake process where if you know that you're making a big change, or if you don't know how to get help making changes, we have a weekly process that basically helps our app teams get up to speed. So within that, right, the previous slide showed the app team on budget, right? What does that actually mean? And this is, if you were to click that, it actually shows you detailed cost information. So this is an app that actually uses one of our auto scaling and like turn off during the weekend capabilities. You can kind of see that in the sinusoidal wave there of the costs. And you can see that we've got some pretty basic unit metrics going on here, right? Monthly cost per account, and then also average cost per day. It's not perfect, but it works because it works for every app. It doesn't matter how many accounts you're in, doesn't matter how many days of the month there are. It's always going to be applicable. And something that we're working on is actually identifying those unit metrics for each app and letting them set their unit metrics, and then showing it right here. So that way they can track it all by themselves. Within that, right, we've got some more detailed information. And again, this is really built for our developers and our product owners and managers that actually build these capabilities that help our customers do banking things every day. Understanding how much your development environments cost compared to your production environments, right? These sorts of things really help drive conversations. It shows what your month-to-date cost is, what your predicted month-to-date cost is. It's yesterday times 30. It's kind of a naive way of doing it, but it's scalable, and it gives people a good idea, a good way to target kind of the outliers. So what happens when you actually exceed a budget or breach a cost? This is a very small budget, obviously, right? $5 a month. And a lot of cloud services can actually be run for less than $5 a month. And so this is one of those, it's a silly example, but it's a poignant example because it shows we have the ability to actually tell our individual application developers what you can do, right? Like delete the infrastructure that you're not using, check our trusted advisor recommendations, convert things, buy things, It helps us kind of drive that conversation again. And this is all customizable based on our APIs and knowledge of those applications. And all of those links in that previous email all drive back, again, using those feedback loops that I talked about earlier. It all drives back to our available monthly, our saving suggestion page within the application itself, where we actually keep track of what they've solved, how many things they've fixed, and also their average time to resolve, which is kind of a cool way to say, like, certain things are more difficult to implement, other things are less difficult, but if you can look at the average, now you can start forecasting and seeing, like, okay, if you wanted to save $74 a month, it would take you 11 days. That's a useful metric for planning. So that's great. Budgets are great, but like things go awry. The problem is the unexpected happens, right? And so from a top level, we use AWS Cost Anomaly Detector in each business unit to actually look at all the different applications. And again, because all of our resources are tagged, we mandate the tag with that application ID, we're able to actually build alerts and automatically target those applications and those developers saying, hey, something really wrong is happening, and you need to kind of look into it because it could cost us lots of money. We also tag ourselves in those emails as well so we can, look around. So here's an example. It was a scary one that we had recently. This is, May 22nd. I think we turned on CloudWatch somewhere. We did something weird. I don't remember. But you can see because of AWS cost anomaly, they know the expected spend versus the actual spend. That's a big increase, 18,000%. But we got this within 15 minutes of it happening, right? And then we were able to do something about it. We didn't actually spend, right? This is saying like it will be $10,000 if you don't do something, right? And so that's a big deal, especially when you have about 300 applications running and building things, and everybody's going crazy, and it can become overwhelming if you don't have these sorts of threshold or these anomaly detectors set up. And that brings us to like our next kind of iteration, right? It's great to have budgets. It's an awesome place to start. It's awesome to have anomaly detections. But at what point do things start happening kind of faster than you can react? And a lot of times, like AWS budget things or other cloud providers, they'll give you like an end of the day, sort of like what happened in terms of your bill. That's great, unless things are actually costing thousands of dollars per hour or thousands of dollars per day, right? You need to know about it like right now, so that way you can save the money. And so that's what AutoMagic App Actions are. We're basically trying to figure out what best action to take in an effort to save money because things look weird. And so we've targeted initially Lambda and ECS. These are serverless services that can kind of spin out of control really quick. And so we always send an email about what happened, what we did to fix it, and how to basically restore service if you actually meant for this to happen, right? So you can see here's actually the runaway Lambda cost spike that encouraged us to build this. You can see our team was spending on average like, what is that, $500 a day? And one day it went up to $3,500 a day. That hurt a lot. And so we decided to do something about it, right? You can use these services and tools to automatically build and understand what your cost environment is doing. And then here is an example email that our application teams get. It's nicely formatted. It says exactly what we did. And a lot of stuff is blanked out there because we don't want to give you our account numbers. But it tells you, right, each one of these functions is actually programmatically built to have its average stored somewhere. And so when you break that threshold, you're actually able to, or we're able to restrict it down to a more reasonable level, right? And so our objective is not to fully cripple the capability of the service, right? A lot of times these application developers aren't purposefully trying to spend lots of money. Just something weird happened, and it can just kind of run away. And so what we do is we'll throttle things down to, you can only invoke one at a time, right? And a lot of the serverless applications are able to, go up to 10,000 invocations at a time, and that can, each one of those adds up really quickly. But by limiting it to one, you're not killing the service, but you're also not letting them do whatever they want, right? And so that's our typical process. We want to throttle, not kill. This is all great for individual app teams. Our executives don't necessarily want that level of granularity. They're more interested in seeing what business unit roll-ups look like, right? Because we do a Showback model. Our executives are more interested in reports that show like outlying applications, right? Like what are my applications that I'm responsible for that are spending the most? Which ones are wasting the most? Things like that. It also helps us forecast. And so you can see here's one of our roll-up dashboards here, heavily redacted. But you can see that I think the important thing is like showing the trend over there. You can see like some apps are going up, or some BUs are going up, some BUs are going down, some are kind of flat. You can see what number of budgets are actually within that application or that business unit, along with some basic metrics like biggest movers month over month, most expensive apps, things like that. It really just helps us drive, again, the conversation from the top down, not just from the bottom, right? So once we have applications that are adopting our best practices, we can not only have the conversation with their development leads, but we can then turn around and have the same conversation with a different spin with their executive, right? And it helps kind of unify the FinOps objective of our platform, which is to drive efficiencies and really make our applications run as well as possible. So here's the outcomes. Here's what we're looking forward to. We got budgets everywhere. They enable best practices through like all those different tools that I briefly showed you guys. We could talk for hours on this. We've doubled our application growth. So we were at 150 applications in AWS. We're now at 336 as of today. And our cloud spend has been flat year over year, which is pretty crazy. Because of our application ID kind of requirements, we've been able to actually kick our legacy accounts kind of to the curb because it just doesn't fit and it's not worth the squeeze anymore. And so our application teams are saying like, okay, fine, we'll get rid of our old AWS accounts and come into these new ones because we get all these cool features for free. And so we've closed 9 of those 10. And then all this data that we have, we drive those feedback loops. Everyone from the interns that join us every summer to our CTO is able to talk using actual data and drive those conversations towards optimization. And that's the FinOps focused culture. So here's the proof. You can see our bill is relatively flat, some bumps along the way. And then our future work, I know we're running low on time here, but again, kind of focusing on actions. What can we do to actually just do it for our app teams? And we've actually rolled this out since we made this. You can actually just go in and click your environments that you no longer want, that are either stale or orphaned from a GitLab branch, and we'll just delete it for you. You don't have to like go in and like do the deletes in the console yourself. We just take care of it. We also have, what are the smart defaults? We like to say like intelligent tiering, right, in S3, or using Graviton or other alternative processors that just cost less but do the same thing. How do we just make that the standard? And then let people get exceptions. And then, like I mentioned, the unit metric costs, trying to identify that in a scalable way for each individual app. It's one thing if your application is enabling people to transfer money, like to and from different accounts, easy, cost per transfer. But if you're a supporting app and you're not sure what that unit metric is, right, that we have to figure out how to have those conversations, and that's why I'm here, trying to figure that out with you all. And then kind of, it's weird, all this work is just one page of this portal that we have. There's this really great capability that that single application ID tag kind of unlocks is, what can we do now with security? What can we do now with developer enablement in order to really get these developers the best role they can? So that was a lot. And I did have another speaker, so please go ahead.
Okay, we can have time for about one question. I saw your hand up in the back first. Give me a moment. Fell off the stage, moving slow. Nah, he needs to hear it.
Thank you. Thanks for in one of your slides, it mentioned that there's a flat cloud spend year on year despite 100% application growth. How is that possible? And the second question is, when you also talked about sending automatic emails when the budget overshoots. So typically, like, where the spend is huge, too much of emails coming, it's like, mails coming for mandatory education in corporate life, which we do it when the boss shouts for the third time.
Right.
So how are you managing that kind of noise with the email alerts?
Yeah, great, and it's a great question. So the first question was, how the heck is cloud spend flat year over year? A lot of work, honestly, and also we discovered a lot of waste initially, right? And so by dropping the waste from those 150 applications, we were actually able to, reduce the cloud spend. But because we doubled, right, we basically got that same price at the end of the day. So really, it's the cloud efficiency metric that we've been able to drive up. We are being more efficient with each individual app. And then the second question was, how do you get your application developers to take you seriously when you're emailing them every 30 seconds? And the answer is you don't. We realized that really quickly, that bombarding people with emails is the least effective way to make people happy. And so what we've done is actually compiled things into a weekly checklist email. And it's like, here's what we've notified, like, here's the important things that you need to know for this week. And then if there's like an actual anomaly, yeah, we'll send that email right away. But if it's something that's just like, hey, we want you to do something different or whatever, we don't want to make them numb to our emails. And so we're being smarter about it. We're figuring out better ways to get those application teams engaged.
All right, let's give a big round of applause for James, especially for this after lunch crew. That is always one of the hardest ones to do.
Thanks for watching that session. I'm sitting here in San Diego right after FinOps X. We hope you join us next year here live 2024. In the meantime, please subscribe to the channel and join the community. Get involved, join the summits, get in a working group, and don't forget to get FinOps certified. Because next year here in San Diego for FinOps X, it's going to be twice as big. Come join the party. Come meet your people. Welcome home.